Assalamu alaikum. Today we are going to discuss the chapter current electricity. The first topic is electric current. We can define the electric current. The rate of flow of electric charges through any cross-sectional area is called electric current. Electric current may flow due to the positive charges. Electric current can also flow due to the free electrons or negative charges. In the case of electrolysis, current is produced due to the flow of both positive and negative charges. In electrolyte, positive ions are attracted to cathode and negative ions are attracted to the anode. This movement of ions within the electrolyte constitute an electric current within the internal circuit. So, in general, you can say that the rate of flow of electric charges may be positive or may be negative. Most of the electric current around us is around us is bound in neutral atoms. It is not easy to overcome the electrostatic force of attraction between the nuclei and the electron in an atom. However, in metals, some electrons are not tightly bound to the nuclei and are free to move randomly around. They have weak forces between them and the nucleus. Similarly, in solution, some positive and negative charges can freely move around randomly. When such free charges are exposed to an external electric field, they move in a specific direction and thus constitute electric current. Electric current is produced due to the flow of either positive charge or negative charge or both of the charges at the same time. In metals, the current is produced only due to the flow of free electrons, negative charges. In case of electrolytes, its molecules in aqueous solution dissociate among positive and negative ions, so the current in electrolyte is produced due to the flow of both positive and negative charges. In general, you can say that rate of flow of electric charge through any cross-sectional area is called electric current. The formula for electric current can be written as electric current is equal to charge divided by time. As the electric current is the flow of charge in specific time, so the relation can be written as current is equal to charge divided by time. Current is represented by capital I, charge is represented by Q, and the time is represented by small t. The SI unit of current is ampere, that is represented by capital A. The smaller units for current is milliampere, microampere. Milliampere is 10 raised to the power minus 3 ampere and microampere is 10 raised to the power minus 6 ampere. Battery is the one of the source of current. The electrochemical reaction inside the battery separate positive and negative electric charges. This separation of charges set a potential difference between the terminals of the battery. When we connect a conducting wire across the terminals of the battery, the charges can move from one terminal to the other terminal. Charges can move from positive to the negative terminal of the battery due to the potential difference. The chemical energy of the battery changes to electrical potential energy. Energy is converted from one form to the other. The chemical energy is converted to the electrical energy here. The electrical potential energy decreases as the charges move around the circuit. This electrical energy can be converted to the other useful form of energy, as the battery is used to switch on the fan, switch on the electric bulb, and for electric bulb the electrical energy is converted into light, and for electric fan the electrical energy is converted into mechanical energy, light energy, sound energy, heat energy. Different forms of the energy can be converted from one form of energy to the other form of energy. In this situation, energy is converted from one form to the other form, but the number of charge carriers remains same. It is the only energy which changes from, but the number of charge carriers and the charge on each carrier always remain the same. Instead of electrical potential energy, we use the term electric potential, which is potential energy per unit charge. Here is another concept of conventional current. We can define the conventional current. Current flowing from positive to negative terminal of the battery due to the flow of positive charges is called conventional current. Before the electric current, the idea of conventional current was introduced. Before the idea of free electrons, which constitute current in metals, it was thought that the current in conductor flowed due to the motion of positive charges, only due to the flow of positive charges. Therefore, this convention is still in use. We can understand the concept of conventional current from the following analogies. We know that when the end of heated copper wire are at different temperature, heat energy flows from the end to higher temperature to the end of the lower temperature. The flow stops when both ends reach at the same temperature. In this and another example is water in a pipe always flow from higher level to the lower level. Similarly, when a conductor is connected to a battery, it pushes charges to flow from higher potential to the lower potential. Higher potential is the positive potential and the lower potential is the negative potential. The charges flow from higher potential to the lower potential, and positive charges are flow from the positive potential to the negative potential. The flow of current constitutes as long as there is a potential difference. If potential difference is not developed, then the charges cannot move from one potential to the other potential. So, conventional current is defined as current flowing from positive to negative terminal of the battery only due to the flow of positive charges is called conventional current. Conventional current also produces the same effect as the current flowing from negative to the positive terminal due to the flow of negative charges. They have no different effect, but we can name it as different because in conventional current only positive charges flow, but in case of electric current generally both positive and negative charges flow. Next is measurement of current. Next is the measurement of current. How we can come to know that current has been established in the conductor, and what is the value of the current in the circuit. Galvanometer and M meter are some common examples of current measuring instrument. Galvanometer is a sensitive instrument that used to detect the current in a circuit. Galvanometer can detect a very small current in the conductor. After some modification, the galvanometer can be converted into M meter, and M meter is also used to measure the current in the circuit. The ranges for galvanometer and M meter are different. Galvanometer is very sensitive instrument and can detect small current in circuit. A current of 5 milliampere is sufficient to cause full-scale deflection in it. While making the connection, polarity of the terminals of galvanometer should be taken into consideration. The terminal of the galvanometer with red color show the positive polarity, while that of with black color shows the negative polarity. An ideal galvanometer should have very small resistance to pass the maximum current in the circuit so that we can measure the maximum current. After suitable modification, the galvanometer can be converted into M meter. After adding small resistance in the M meter, galvanometer is converted into M meter. The range, a large current range such as 1 ampere to 10 ampere can be measured by using M meter. The galvanometer and M meter are connected in series in the circuit because the in series combination the current is same. We connected the M meter or galvanometer in series so that total current can pass through it, and we can measure the exact value of current that is flowing in the circuit.